So the Cape Verdes are this cluster of volcanic islands off the west coast of Africa. And they are really interesting for geologists because these islands, unlike most other islands in the world, they are slowly rising. So I started coming to Cape Verde in 2005 when I started my PhD. And we found this very strange boulders stranded on a very high volcanic plateau. At the time we didn't think much about it, but later I was speaking with one of my colleagues in Lisbon. He told me that he has found tsunami deposits lower down in other parts of the island. And that's when we suddenly realized that those boulders were probably part of a tsunami deposit. So we went back and started mapping them, and we actually found much more of them. And then what was a crazy idea became a feasible hypothesis. So just 50 miles offshore of Santiago Island, where we found these deposits, there's this huge volcano, Fogo, which is one of the most prominent and active oceanic volcanoes on Earth. And sometime in the past, a flank of Fogo collapsed into the ocean in between 65 and 84,000 years ago, and it generated this massive wave that inundated Santiago up to an elevation about 880 feet or more, which is about 10 to 15 times higher than any earthquake-triggered tsunami like the Fukushima tsunami. It's higher than Eiffel Tower. The incoming wave came onto the coast. It quarried boulders from the cliff edge, from the very massive lava flow we see here in the background, onto the surface of the plateau. As you can see, in the boulder there's these columns. This is formed when the submarine lava flow was cooling. This originally is formed vertically. Now you can see that the boulder here is stranded. The columns that were originally vertically are now in horizontal. So I literally chisel with the hammer and chisel at the top surface, and then use that to extract olivines and by mineral separation. And then with those olivines we measure what's the cosmogenic helium isotopic composition.
We measure helium-3 because that provides us with a clock. We know that once the boulder is put there, it's exposed to the air, and more importantly, it's exposed to tiny particles that come from outer space with cosmic radiation. And those tiny particles do a reaction in the surface of the rock, and they produce helium-3 with time. And the more time elapses, the more of that helium-3 gets produced. So when we measure how many helium-3 atoms are in that rock, we know how much time has elapsed since that huge tsunami wave put those huge boulders up on the plateau.
We know the age of the collapse, and we've dated the deposition of the boulders, and the two ages match. So we have really good evidence that these two things are connected, and so we know that this collapse triggered this giant tsunami that created the deposits we've studied.
Now we've done it in the Cape Verde Islands, and we have the tools now in place with that helium-3 dating method to do this all over the world.
Fantastic eruption, but with a downside that the human side, which displaced more than 1,200 people that lost their homes due to the lava flows that destroyed the village where they were. From the scientific point of view, the eruption was absolutely fantastic. It was an amazing firework of magma being injected into the air and producing all this lava flows. The Cape Verde is a fantastic place. It's a warm country with a very warm culture. People are extremely friendly. The food is amazing. Brilliant music too. So it's really nice to work there.